In this lesson, you're going to learn how to add and subtract polynomials. Let's go over a big idea that sometimes students get mixed up with. If I told you to do x squared plus 4x squared, well, they are like terms because they both have an x squared. So you would end up adding the coefficients and you keep the variable part. So it's 5x squared. Whereas if I asked you to do 1x squared times 4x squared, the difference here is you multiply coefficients, so 1 times 4 is 4, and x squared times x squared is keep your base and you add your exponents. So this would become 4x to the fourth. So you must have like terms in order to add. If I told you to do x cubed plus 5x squared, you can't because they are not like. But you could multiply them together. X cubed times 5x squared would be multiply your coefficients to get 5 and keep the x and add the exponents, so it would be 5x to the fifth. So let's look at how to add polynomials together. So here I have a cubic polynomial added to a cubic trinomial. Because it's addition, the nice thing is you really can just ignore the grouping symbols. So I've recopied each of these polynomials and got rid of their parentheses. So now what I'm going to do is I'm going to look for like terms, and I always start with the highest degree. So I see a 2x cubed plus another x cubed. Combine the coefficients, keep the variable part. So this would be 3x to the third. Then I look for squareds. So I see a negative 5x squared plus 6x squared. Combine your coefficients to get positive 1x squared. Then I go for the x to the first power. I only see a 3x, so I'm just going to recopy that. And then there's the constant of plus 11 at the end. This is simplified. Remind you of some vocabulary. This would be a cubic polynomial. The leading coefficient would be 3. It has 1, 2, 3, 4 terms, and the constant is 11. So again, I have an addition problem. So I can recopy this trinomial and this one without the grouping symbols. So I've recopied it without the parentheses. And you notice right here where I had a plus, a negative. I just made this a minus because I like just one symbol. I don't like the clutter of two. So now I'm going to combine my like terms. So my highest degree is a 3. So I have 3y to the third. Now I go to the squareds. Here I have a negative 2y squared minus 4y squared would be negative 6y squared. Cross these off. Now I go for the y to the first. So I have a negative 7y to the first plus 2y would be a negative 5y. And then I have a constant of negative 5. So I have a cubic trinomial. It has 4 terms. The constant term is negative 5. My leading coefficient is 3, and the degree is 3. Subtraction works very similarly. There's just one extra step. So notice again, I have a minus sign. So I can recopy this first one without parentheses, but the second one, I'm going to have to do something a little extra special here. I need to remember that there is a negative 1 as a coefficient. So I'm actually going to distribute this negative 1. So I'm just going to recopy the 3x to the third plus 2x squared minus x plus 7. Now I'll have negative 1 times 8x cubed would be minus 8x cubed plus x squared plus 5x minus 1. Now, something I always do is whenever I distribute a minus, I make sure every sign switched. So this was positive, it's negative. This was negative, now it's positive. This was negative, now positive. Positive switched to negative. Now I'm ready to combine my like terms. So my highest degree is 3x cubed, and a negative 8x cubed becomes negative 5x cubed. Now I look for my squared. So I have a positive 2x squared plus 1x squared would be plus 3x squared. Look for my linear terms. I have a negative x plus 5x would be a positive 4x, because coefficient right here would be negative 1. Negative 1 plus 5 would be 4. On to my constants, I have a positive 7 and negative 1 combines to be positive 6. So again, I've got a cubic polynomial here. The leading coefficient is negative 5, degree is 3, constant term is 6. Altogether, there are 4 terms. Our fourth example is also subtraction. So I can recopy this first as 4z squared plus 9z minus 12. I need to again remember that my coefficient in front of this second one is a negative 1. So I'm going to distribute this negative 1 to get negative 5z squared plus z minus 3. Now I will combine my like terms. So my highest degree is 2. I see a 4z squared minus 5z squared would be negative 1, or just negative z squared. On to my linear terms. I have a positive 9z plus 1z would be 10z. And then to my constants last would give me a negative 12 minus 3 would be negative 15. My polynomial is simplified. It would be quadratic. The leading coefficient would be negative 1. It's a quadratic trinomial because it has 3 terms and my constant term is negative 15. Lastly, let's look at an application question. The annual amount of waste in millions of tons generated in the United States is approximated by g of t, which is shown on your screen, where t is the number of years after 1960. The amount of waste that is recovered can be approximated by r of t. So that's probably like through recycling. Estimate the amount of waste that is actually wasted. So we're going to take the total waste and subtract the amount that is recycled. So I am going to subtract, and I have 0.001 t to the third, which there's nothing like with this, so I'm just going to rewrite it. Then I'm going to combine the squared terms. So I have 0.06 t squared minus 0.06 t squared, so these will cancel. Then I'm going to have 2.6 t minus negative 0.59 t. So notice I'm not in this problem, I didn't distribute the negative first, but you'll still get the same answer if you carefully go 2.6 minus a negative, which is 3.19, and then combine your constants. So we have 88.6 minus 6.4 would be a positive 82.2. So that is the function that would show you the general amount of waste. Now predict how much is wasted in 2020. Well, T was the years since 1960, so that would be 60 years later. So if you plug in 60 everywhere there is a T, and then use your calculator to evaluate this function, you will have it. So I'll press pause, do this calculation, and see if you agree with me. So I get 489.6, and this would be millions of tons. That's a lot of garbage here in the US. Please excuse my sloppy handwriting on this slide. My stylus happened to break just as I was recording today. All right, if you have any questions, reach out to me.